Hey everybody, and welcome to the next video for the project Build a Data Analysis Library from Scratch in Python. In this video we are going to be completing step 3, Convert Unicode Arrays to Object. So back here in our data frame class, we are still in our constructor. So the first step we ran this check input types method. In the second step we ran this check array lengths method. And now we're right here. So our data at this point is guaranteed to be a dictionary of strings mapped to one-dimensional NumPy arrays where all the NumPy arrays are the exact same length. So in this method what we're going to be doing is converting any arrays that are of data type Unicode into this data type called object. So we haven't said anything about the data types of the NumPy arrays that are going to be inside of our data frame. So we are going to allow basically any data type, except for this Unicode data type. We're going to convert it into an object. So if our user gives us a Unicode NumPy array, we are going to convert it to an object array. So I want to spend a little bit of time covering data types in NumPy just so that you can have a better idea of what they are. I have a link in the README where you can read much more about them, but I want to show a few examples here. So yes, our data frame will be composed of one-dimensional NumPy arrays. Every NumPy array has a data type. So let's just go ahead and look at some of these. So if we import NumPy as np, we will be, I'll just create some arrays. Let's see here. So let's first create an array of some just Boolean values. Say we have an array of true and false. It's a simple one-dimensional array with 2 elements, and it has type bool. Alright, so let's keep going. Let's create another array, and this time we'll create some integers. And I'll use the dtype parameter or dtype attribute once again to access the underlying data type. And in this case we have a 64-bit integer, so that's what the 64 is, but it is integer. So we can also create floats with NumPy. So here is a NumPy array that is composed of floats. So if we retrieve the data type with the dtype attribute once again, we can verify that we do have a NumPy array with a float data type, a 64-bit float. Now where things get a little bit interesting is whenever we create strings. So I'm just going to reproduce this data over here in the README. So if you create an array of strings, NumPy will return this kind of cryptic data type. It says U5. So this is the capital uppercase U stands for Unicode. 5 is the length of the maximum length of string that you gave it. So snake here has 5 characters, so it's U5. Now, the issue with these Unicode arrays in NumPy is that they are not very flexible. So for instance, if I wanted to overwrite cat with, say, elephant, so I'm going to overwrite the very first element in this array with elephant, this code completes without an error. But if I look at the underlying NumPy array, you can see that it only captured the first 5 characters. So each element in this array has a maximum of 5 characters. The other thing that is not flexible is, let's say we want to set this equal to a missing value, say something like none. Well, then this also completes without error, but if you look at the underlying data, it has turned it into the string none. So that's not ideal if we want to have missing values in our arrays. So what we are going to do is we're going to use a more flexible data type called object. So object is just a catch-all data type in NumPy, which allows any Python object to be in an array. So you can put any object in there. There's no restriction. So you can mix numbers and strings with none or whatever, and that's valid. So we're gonna do that. That's actually what Pandas does. So we're copying Pandas in this instance. Pandas does not have a Unicode a data type for any of its columns. It uses the NumPy object. So we're just going to follow in its footsteps and do that conversion so that our strings our string columns can be a little bit more flexible. Okay, so one thing before we get there is that as you saw, these data types, integers, they have the number of bits appended to them. But so if we want to get what we're going to do is get the data type kind to identify it. So this is a single character that will identify, basically just its generic data type. So just so I can show you that, so here's A again, which is Boolean. But if we use the kind attribute of the D type, you'll get a single character string. So same with integers. We're going to use this kind. We're going to get back I. And the reason I'm showing you this is that it's easier to deal with the kind, which is just a single character, than worry about this object like this. This is a much bulkier object. And so it's just easier if we check for the kind. So, and the last one, of course, is the Unicode one, is U. So, what we're going to do now in our code is if we come across an array that has a kind of U, we are going to convert it to object. And we use the as type method to do the conversion. So the way we do this, so here's D. It's still a Unicode array. So what we'll do in our code is we'll do as type, and we'll type in the string object, and that will make the conversion to this object array. So if we just call this O, for instance, as object array, then now we can put in anything in here. So I can put in the string elephant, and it will it will put that exact object in there, and nothing will get cut off anymore. So hopefully I've convinced you that's why we're using object. It's just a simple way to make our column of strings more flexible. So let's hop down here to this convert Unicode to object array. Now there is a couple lines of code that have already been written. So what we're going to do is we are going to use this new data dictionary to take the place, to hold all of the new data. So actually all of the data for our data frame. So instead of changing this dictionary itself, we're just going to simply place it, place the contents in this new data dictionary, and then just return that. And that's what eventually will get stored in the underscore data instance attribute. Okay, so what we want to do here is iterate through this through our data dictionary. So for key comma value in data.items. So what we're going to do is a simple check. If value, so value is a NumPy array. If the kind is U, we will go ahead and assign this to new data, and we'll just use key again. Right? So we're just going to replicate the same thing, but we are going to use as type here, and I'm going to put in object. Otherwise, we'll just keep new data. We won't change the data type of our NumPy array. So that's all we're going to do here. And so anytime a user gives us NumPy arrays that have the Unicode data type, we're going to convert that array to as type. So this should work. So let's go ahead and run the test at the bottom of here. So it says test Unicode, this is the test underscore Unicode to object. So I didn't give the entire test name, so I'm going to have to type it out. So Unicode to object. And let's see if this passes. And it does. So that's good. So one passed, and it's green, the green dot. So we've passed that test. So we've correctly converted our Unicode arrays to object. Okay, so that does it for step 3, and we're going to move on, keep on going and move on to step 4 in the next one.